I think we can start slowly but surely. Uh, yeah. Okay. So the purpose of this lesson is to tell about how to write proper functions, how to write functions which are easy to read and understand, how to write functions which are maintainable and reusable, as little coupled as possible. So let's get started. So this lesson will be split in two parts. First part will be about functions which do one thing and do it well, and second part will be about functions which are small. So do one thing. And there is a nice quote by Robert C. Martin, which goes like this: functions should do one thing. They should do it well. They should do it only. So no side effects and perfectionism at small tasks. That's the ideal function that there should be. So functions should not have any side effects. You read the name of a function and you expect it to do that thing and nothing else. Here we have a constructor. What do we expect in a constructor? We expect it to only create something, and that's it. It should not do anything else other than creating um, of objects of that class, making instances. Here we see that it logs as well, and that sentence should be removed. Uh, the best way to go around this to have a factory which has a responsibility of creating different objects, and whenever a different object is created, if needed, uh, you can do the logging there. Even better, you can fire up an event, and then logger itself will log whenever needed the thing that needs to be logged. So another important thing which is often missed in functions is that they should not mix levels of abstraction. If a function uh, does high level stuff, you shouldn't mix low level stuff in it. So in this example, we have a function run simulation, which does logging, which does casting, which stops console, pauses our input, and which also logs again. How we can make this better is by um, by moving the logging statements in the main method. So moving the logging to where it belongs, not in the run, but in some higher level module, because run is a bit lower level module. And in the end, we should get rid of logging altogether, as we don't want to bind our application to logging every time whenever something happens inside the run. So we would like to ideally have an event and subscribe to an event which logs what we want. So that's the best way to do it. Because right now, the third refactored version of this code shoots an event, and our program subscribes to an event which does the logging. So now we don't have to have things that we don't need, and we don't have to mix different responsibilities, as in running simulation should only simulate logic, of that domain and nothing else. Logging is not simulating logic, so it should be split. By splitting it in the main, we make our function do a single thing and we don't mix levels of abstraction. Another thing is that a function should not mix commands and queries. Command is something that we want. Command is a bunch of criteria based on which we retrieve something that we need. Sorry, that's a query. Query is a bunch of criteria that we want to use in order to retrieve something, and command is something which executes our query, our criteria based on which we retrieve stuff. So the two should be separated. The two should be separate entities. Our command should execute query, and based on that we get the results with which we can work on. So in this case, in the first case, we have getCaster, which creates a command and feeds it to the SQL executor, which is not the best thing because we want the query separated. What if we want to change the query? We would have to change the whole method together. What if we want to execute a different query? Then we would have to have a duplicate code for executing query, so it's really not the best thing to do. That's why command and query should be both separated, because it makes it more reusable and loosely coupled. When you have events and entry functions or functions which happen at a certain point, for example in Windows Forms application or in any other application really, as long as it's exposed, the main method, as long as it's exposed, you can put essentially your whole application's logic in it, but you should not. Main should have only the highest level logic. So in my first case, basically my whole logic of application is in the main method, and it's a mess. I create spells, a caster, dummy, and then I test my casting and I see the output. Pause it before it terminates. It does a lot. It does everything that I want, yet it should not. I should somehow model the highest level concept that the program does in the main. What does it do? It executes a simulation. It runs the simulation. So what do I need to do? In the example below, you see that I created a new simulation and that I ran it. That's all that there is. So two things: create a simulation and run it. That's all I should care in the highest level. So event handlers should never contain implementation. They should just call highest level functions which tell what I want them to do. Exceptions are for really trivial event handlers like this one, where all my event handler does is logs something to the console. It's the lowest level, and a single line of code to be executed, that's good enough for event handler, not to be put in a separate function. So what are the benefits? Of course, the code will be loosely coupled. It will be reusable beyond the project scope, which means that whenever you wrote something that is potentially reusable, for example, if you had to make an application which reads some data from Excel, and if you come up with a better way of reading Excel rows, tables, sheets, and so on and so forth, you can easily move the logic of the project outside that project if you follow those rules of loosely coupled functions, of functions which are doing one thing and doing it well. When you have when you follow those rules of function doing one thing and doing it well, you somehow can trust that a function will not fail and that it will not have any side effects. You gain reliability and trust in your and others' code if you know that someone else followed the rules. And of course, when you need to add a single step, or when you want to change something in your code, in existing code, it's much easier, much more easier to change uh, a sentence rather than a bunch of words, because because if you don't really understand how to write a sentence, no, if you don't really understand how to compose different words, it's much easier to just put a sentence and shove it in a chapter rather than trying to compose your own sentence. You can reference, take an example for an English test. When you're starting to learn English, it's much easier to put sentences in the right order than to put individual words from those sentences in the right order. So that's what I meant by easier changes. And you can compose sentences that way, because your functions are supposed to be doing one thing, doing it well, and be composable. So another part of this is functions which are supposed to be small, short, and concise, just like poetry. So if you look at functions in code and read them from top to bottom, at the top you should see the highest level functions, and at the bottom you should see the lowest level functions. Highest level functions should depend on lower level functions. I would change this and say that lower level functions should not depend on higher level functions. So you shouldn't expect something at the bottom to be using something at the top, but you might expect something at the top to be using something at the bottom. That's perfectly fine. So functions are like a chapter of a book. You read them from top to down, and when you want to look up the details, you will look down. You will look at up if you want to know the abstract idea of what the class does, and you will look down if you want to understand the details, usually. And after this I'll give some examples. This rule about functions having few arguments is a bit tricky. I think since frameworks and in general basically everyone violates this rule, it's really hard to understand it. And it's really strange sounding when you say that a function which has 0 arguments is the easiest function to read. But how can a function which operates on data have no arguments, you might ask? Well, first you can create an object which encapsulates and abstracts away your data and functionality. So now you have data in some container object, and that container object also has abstracted away a bunch of functions that you want to operate with on the data you have encapsulated. So that's how you can achieve functions with 0 arguments. So the more the arguments the function has, the more difficult it is to read, and if it has more than 2 arguments, you should consider refactoring it. So how do we refactor a function with many arguments? The first step is class. First, you should consider if a lump of data that you're operating on can be grouped into a function, into a class, and can that class have an abstraction of methods in a higher level on which the encapsulated data can be operated on. And if the answer is yes, go ahead, make a class, and like that you can achieve methods with 0 arguments. Second way of doing it is grouping arguments together. For example, I could A, pass x and y as coordinates, but I know that x and y is a point essentially. So instead of passing a point, which is instead of passing 2 parameters, which is 2 floats for x and y, I could pass a point, which is, let's say, a 2D vector. And like this, I can avoid 2 parameters and have 1. Like this, my function becomes more readable and easier to understand. And that's all I wanted to say for now. And let me show you the concept that I want to demonstrate of a function which has higher level concept and then lower level concept going down. So let's see what we could do. My repository, if I go to my repository, I will rename it repository. You can see that this is the function that is at the highest level. It's a function that I expose as public. And this is the function I'll call. All of the functions are private and they're not visible to the outside. And getCaster by ID query comes as a lower level module, and thus it is down here. If, let's say, the SQL was complex, I could have done something like this. Private string get player select query SQL. So I can do something like this, and this can now become something like this. Okay, so this is high level function. This is a bit lower level function. This is very low level function, just a string lump of text. This is converting that lump of text into SQL command, and this is executing SQL command. So you see a dependency, a chain of dependencies in terms of functions, which go down below. And and this is not the best example, but let's make another one. Let's say we have a name. No, let's say we have a name. So let's say we have a BMI calculator, body mass index. CS BMI calculator. It'll be a static class. So our BMI, public static float, calculate v1. The first version takes string name, float height, and float weight. So it returns, let's say name is not needed. It returns const index h 0.8. I'm not sure how it's calculated, so I'm just doing some bullshit calculation, but the concept remains. Weight and height 0.9. So let's say you just multiply those together. Height from weight times index h times index b. Let's say f and f, and that's it. So our version 1 takes height and weight, but those are something like properties of a person. So if you just have a person and take those two from a person, you now have a single parameter instead of two. So height and weight. And like that you have reduced number of parameters needed. This might not be the best example, as you might not want to pass a person as a parameter, but it's one of the ways. Other way would be more stupid, which is no, I won't show that one. It's more like you load a person and then you keep calculating based on that person, so you don't need to pass any arguments, but that would not be the wisest implementation. Okay. I think the most interesting one was where you have, like, how can you split logging or any other action inside a key point of a function. For example, if it failed, you want to do something without doing more than a function should do, or if it succeeded, or if it started, or if it updated the database. And whenever you update the database, you want to do something, there are ways how you can do that something without violating single responsibility principle, which is doing it outside. So the key point here is having events. Events are still a part of your function. You signal when a function starts or ends. Right here or here. It started, it ended. And this is still a part of a simulation. It's still a part of a run function. It's still a part of what this function does. You don't violate it. You still do the same thing. And outside now you expose those key points of a function to be handled. So now you can handle them through event handlers. And now my logging is completely independent of simulation, of running simulation. So to sum up this lesson, I'll say that the fewer arguments a function has, the better. The smaller a function is, the better. And the function should not mix its levels of abstraction. Thus, making the function reusable, robust, and easy to read and easy to understand. Thank you for the lesson, for listening me, and